Welcome to presentation 35. Today's subject is going to be display graphics. The display graphic is part of our layer 3 display capability, and we're going to be using from layer 2 the SPI framework and the IO port framework. The agenda for today is going to be, I'm going to show you the setup, then I'm going to develop the algorithm for drawing lines. We'll go through a couple of sample programs. Next, I'm going to develop the algorithm for drawing circles. And again, we'll go through a couple of sample program, and finally we'll go through the summary. So let's get started. So the setup, what we are going to have is we have our ATMEGA 328 is going to be hooked up to the hex non-inverting buffer DIP, the 4050, and in turn that's going to be hooked up to the display. The reason we need the 4050 is because the display is a 3-volt logic display, so we will see this to down from 5 to 3 volts. So let's talk about the algorithm for the line. So what I have here is I'm showing 3 dots, a dot blue which is at location x, y, a yellow dot which is at location x, y plus 1/2, and then a third dot which is red which is at location x, y plus 1. And then I have a line, and the one point in the line is going to be the x, y1. Now the yellow dot is between the halfway between the red and the blue. The line is below the y dot, which is at the center, and x, y is a point on the line. Now the equation for the line is the mx plus b minus y0. Now, if I call a variable y2 and make it equal to y plus 1/2, which is the y coordinates for the yellow dot, and from the picture we know that y2 would be greater than y1, because we have a y2 is greater. y2 is equal to y plus 1/2, which is above y1. Now, next, if I plug in y2 into this equation, then the equation is going to be less than 0. Basically, what we had here is mx plus b minus y is equal to 0. So if we increment y1, then the equation turns out to be less than 0. Now, the interesting to see here is that the line is going to be closer to the blue dot. So if this equation is less than 0, then the line is closer to the blue line than the red line. So let's look at another setup. In this case, we have our red, yellow, and blue dot again. So what I've changed is I've placed the location of the line above the yellow dot, which is at the middle between the red and the blue. So again, I have my equation mx plus b minus y1 equal to 0. So y1 is the a point on the line. Now I define my y2, which is going to be y1 plus 1/2. And of course that y2 is going to be less than y1, because y1 is up here, y2 is below. And if I plug in this into this equation, so this equation was 0. So if I decrement y, make y smaller, then this equation is going to be greater than 0. Now what I notice is if this equation is greater than 0, then the line is closer to the red dot than the blue. So what I wanted to show you in this example is if I have three lines, and the blue, the red, and the yellow is at the center, and I plug in this value into the equation, and the value is less than 0, then the line would be closer to the bottom dot. If the equation, once plug in the number, the value comes above positive, then the line is above the yellow, the middle point, which is the yellow dot, and closer to the top. So if I had to select, if we assume that this is the red is a pixel and the blue is a pixel, and a line is going to go across, and I plug in the value of the center between these two pixels, and the equation turns out to be less than 0, then I should say that the blue dot is closer to the line. However, if I do the same thing, I have a line and I have between two pixels, and I plug in the mid value between these 2 points into the equation, and I end up with equation greater than 0, then I can say that the line is closer to the red pixel. So let's continue with the next. So this, what I have here is I'm trying to show is all the pixels on the display. So what I need to do first place, I need to draw this line. That's my assignment. They give me the initial point and the final pixel where the line has to go. But I need to be able to identify every pixel here in my display. So what I'm going to do is I'm going to set up an X and Y coordinates. And for example, this first pixel is going to be at X comma Y. This one is going to be at X plus 1 comma Y, and so forth and so on. So now I can access any of this. I can identify, I should say, any of these pixels. So I got the assignment to draw this line, and I know they gave me the initial value and the final value. So I know those values, so I can light up these 2 pixels. Turn on LED, the first one and light one anytime I want. So I can start by doing the first one if I want to. Next, once I light up this, now I'm going to go to the next, I'm going to go to X plus 1, which is the next pixel. However, the line is in between these 2. So I need to figure out which of these pixels I'm going to light up. So what I do is find the middle point coordinate between the 2 possible alternatives, which is going to be Y plus 1/2. So the middle point here, this middle point is going to be, between these 2 is going to be Y plus 1/2. That's the middle point here. So the next thing I'm going to do is, as I noted before, I'm going to plug in this Y plus 1/2 into the equation of the line, my MX plus B, because I'll show that I can define this line very well with just having the initial and the final point. And then I can evaluate the value. If I plug it into the equation, it's 0, that means that this line is exactly on the middle, and I can select either point. Now, as before, if it's less than 0, then I should light up the bottom pixel, because that means that the line is closer to the bottom pixel. If it's greater than 0, then I light up the top pixel, because the line is closer to that particular pixel. So in this case, oh, and one other thing, once I've selected with one of these 2, The next thing I have to do, I'm going to increment x. So I'm going to go to the next pixel. I'm going to increment x plus 2. And then I would, if I select the bottom LED, then I do not increment y, but I just increment x. If I select the top pixel, I should say, then I would increment x and increment y. So let's continue here. So in this case, I selected this pixel. Next, I got x plus 1. And as I selected this pixel, the bottom one, then I didn't change one. Then I made this calculation, and then I selected the top one. And then I continue to go on and on till I've completed my my line. So the trick is I plug into the equation, and then I figure out if it's 0, less than 0, or greater than 0. Then I select the top of the bottom or the bottom pixel based on that. And then I always increment x, but the y I'm only going to increment if I selected the top pixel. So let's look at some of the how we did develop this in the equations. So I need to plug into the equation the starting value, which is x sub I plus 1, y plus 1/2. So I'm going to plug that into the equation to get my first equation, which I'm going to evaluate whether it's equal to 0, less than 0, or greater than 0. Now let me do a preamble here and look at this equation, because I'm going to put it in a different way, which is going to be easier for the development of my equations. So I got initially the xi, yi, and x final and y final. So what I'm going to do here is I can calculate the slope, which is dy dx with those particular numbers. Next, the equation of the line then becomes dy dx times x plus b minus y. Then I can multiply the whole equation by dx to get rid of the division. And I finally end up with an equation which is dyx plus dxv minus dx times y equal to 0. So I haven't really done anything magical here. I've done is just plug in the values. So in this equation, I'm going to plug in this particular value that I need to analyze to see whether it's greater, equal, or less than 0. So I plug it into the equation, and then I continue to develop that equation. And so I get to this point. So I have dy x sub I dv dx times b dx times y1 dy and minus dx divided by 2. So, but I know that this dyx dxb dxy is equal to 0 from this equation. So I can take this term out of the equation because it's 0. So then that leaves me with equation which is going to be dy minus dx divided by 2. The rest went away because it's equal to 0. Next, I multiply everything by 2 just to get rid of this division. And what I end up is with equation which is 2 dy minus dx equal to 0. So if I evaluate this equation, then basically, if it's 0, I can select top or bottom. If it's less than 0, I select the bottom. If it's greater than 0, I select the top. Because this equation is equivalent to the one where I plug in my numbers, as I showed you at the beginning. So I can evaluate that. So the first thing I do is, when I need to draw the line, is I select my initial, I can light up my initial pixel, and then I can plug in my numbers into this equation to see whether or not what I need to do next. So let's continue here. So let's do the same operation now, But this time what we're going to do is we're going to increment x plus 1, but we're going to leave y remain the same. The idea is here that I'm going to plug into the equation the case where y remains the same and x is increased. So the value that I plug into this equation is going to be x sub I plus 2 comma y plus 1/2, because it has not changed. So when I go ahead and plug it into my equation and develop the equation, then similar as before, I'm going to get to the point that part of the equation is equal to 0. So we can, all we need to, what is left is 2 dy minus dx divided by 2 equal to 0. This other portion goes away because it's equal to 0, as I showed you before. So multiplying the equation by 2 for simplification, we get this particular equation, 4 dy minus dx, 0. But then what I notice here is that our first equation was 2 dy minus dx. So that would be 2 dy minus dx. So if I break this, this 4 dy into 2 dy plus 2 dy, then what I ended up is I have 2 dy plus 2 dy minus dx. But this portion here is my equation 1. So my equation 2 is going to be equal to equation 1 plus 2 dy. So if I have a case where the y was not incremented, then I know that the next evaluation I have to do, I have to take my equation 1, which is this particular value, and I have to add the 2 dy, and then I have to evaluate that for 0, greater than 0, and less than 0 to determine which pixel I'm going to light up. So now let's look at the equation where x is incremented and y is also incremented. So in this case would be x plus 3, and the y would be y plus 3/2. So this is the value we have to evaluate, and then we plug it into the equation again. So we get this value, and then we expand the equation and continue to resolve the equation till the point as before we get to the portion of the equation that is 0, and then we get left with 3 dy plus 3/2 of dx equal to 0. Now we are going to multiply everything by 2 to simplify, and what we end up is with an equation which is 6 dy minus 3 dx. Then we expand this, and what we're going to realize that portion of this equation is actually equation 2, which is 4 dy minus dx. So this whole portion is really equation 2. So what we end up and from this equation is that the new equation, when we change x and y, is going to be equal to the equation 2, or I would say the equation that was developed priorly, the results of the equation that was developed plus minus 2 dy dx, which is, so we have equation 2 plus this new number. So what we have to do is we have to evaluate this for 0, greater than 0, or less than 0. So now let's continue and look at how we put this whole thing together. One of the things that we need to consider is if the slope of the line is more vertical than horizontal. And this is going to be true if the slope of the line is between -1, less than -1 I should say, or greater than 1. In that case, what we do is we calculate x and increment y. The other thing that we have to look at, the other option that we have to evaluate is if the slope of the line is more horizontal than vertical, like here, that means that the slope of the line is less than 1 or greater than -1. In that case, what we do is we're going to increment x and calculate y and increment x. That's what I should say. So how do we do this in C code? So we're going to ask if the absolute value of the slope is less than 1, then we're going to increment x and calculate y. That would be this case here. Next, else if the absolute value of the slope is greater than 1, which would be this case, then what we're going to do is we're going to calculate x and increment y. Another thing that we have to consider is the value of the slope. If the slope is positive or if the slope is negative. If the slope is positive, then we're going to do the following. The initial value is going to be equal to dy minus dx. And we're going to calculate the next y by adding one of these two values. 2 times dy minus dx, that's if the y is incremented, or we're going to be adding 2 times dy if the value of y remains the same. That's for the positive slope. That's going to be zone 1, 2, 5, and 6. Next, we're going to do the following if the slope is negative. The initial value is going to be minus 2 times dy minus dx. And we're going to calculate the next y by adding one of the two values. Minus 2 times dy plus dx, that's if the y is incremented, or we're going to add minus 2y if the value of y remains the same. Now let's look at the code to do all these things. So the starting routine is going to be draw line, and it's going to have the inputs to that routine. It's going to be the color, the x start and y start, and the xn and yn. Those are the coordinates for the start of the line, x start, y start, and for the end of the line, xn and yn. So one of the things that the first thing we're going to evaluate here is whether or not the line is vertical. So what we do is we subtract x start minus xn. If that's 0, that means that the line is vertical because it has the same value for x, and what changes is y. Now, before we do anything to this with this the start coordinates and the end coordinates, we need to make sure that the start coordinate are less than the end coordinates. Otherwise, we have to swap them around. The reason is, for example, let's look at this picture. For example, in this case, if they give us the initial coordinates are at this point and the final coordinates are at this point, then the x and y initial are less than the x and y final coordinates, and that's what we want to have always. The initial values less than the final values, and in this case it would work just fine. However, it could be that the user decides that they want to give us, they want to draw a line between this point and this corner, and they could very reasonable say that this is the start point and this is the end point, in which case the initial coordinates are going to be greater than the final coordinates. See, x here is greater than this x, and y is greater than this y. and the 0, point would be in this corner. So no matter what we have to make sure is that the initial coordinates are less than the coordinates. So if they give us this coordinate first and then the next one, what we have to do is we have to swap things around. So let's go back to our code. So that's the first thing we do here. So first we make sure that, we look at the if statement, tells us that we have a vertical line. So what we do here is we make sure that the y start is going to be, we looked at the y, if the y star is greater than the n value, then we have to swap things around. Otherwise we leave everything the same. So here in the plot where everything stays the same, we would have color, we have the x star, y star, xn, and yn. In this case, it's going to be the opposite. We are going to have the x start and the yn, then we have the xn and the y start. So let's look at our next if statement. So we're going to look at this case. We go from this point up to this location. So we ask, hey, is the x start less than the xn? And that's true. The x value at the start is less than the x value at the end. And then we ask, is the y start less than the yn? And that's going to be also true because the y start is at this point and the yn is going to be true. So if these two statements are true, then we say that we're in zone 1 and 2. Now the next question we can ask is, we ask if the x star is greater than the xn. If the x star is greater than the xn, that would be true because the x star is greater than the xn. And then we ask if the y star and the y star is greater than the yn. The y star is greater than the yn. So what this line is saying is if this is either of these is true, then what it says that the line is going to be in zone 1, zone 2, zone 5, or zone 6. So it's basically a line that comes in this direction. Now, if this is not true, then what we have is a line that goes in this direction. So that would be a line that goes between 3, 4 and 7, 8. So that's 3, 4 and 7, 8. So basically in this routine we ask, hey, do we have a vertical line? And if the answer is no, then we go and figure out, hey, is this a line that goes between zone 5, 6 and 1 and 2, or is it a line that goes between zone 7, 8 and 3 and 4? So according to that, we are going to call one of these routines, which is draw zone 1, 2, 5, 6, 1, 2, 5, 6, which would be this line, or draw zone 3, 4, 7, 8, 3, 4, 7, 8. So let's go and look at those routines. So again, we have draw a line that is zone 1, 2, 5, 6. So what we have as input, we're going to have the color of the line we want. Then we have the x and y initial points, what I call the star. And then we're going to have the x and y endpoints, which is xn and yn. So we have a number of things that we, parameters that we defined here. And the first question we're going to do is we're going to make sure that the initial values are always less than the final value. So in this case, the star, both of the star are greater than the endpoints. So what we're going to do is we're going to swap. So we're going to say x initially, we're going to call it xn. Then y initially is going to be yn, and the x final is going to be equal to x star, and the y final is going to be equal to the y star. So all we're doing is just making sure that the initial values of those coordinates are greater than, are less than the final value. In this case, I don't have to do anything because that's the way they send the parameters. So we have x initial is x star, x final is xn, y initial is y star, and y final is yn. Next, I'm going to calculate the dy, which is y final minus y initial, and then I have the dx, which is x final minus x initial, and then I calculate the slope, which is dy dx. Now I have this parameter, which is called the middle line, which is the initial value, which we already looked at, which is 2 times dy minus dx. And then we have a what we're going to use if the value that we calculated of the initial of this line is greater than 0, then we're going to add the 2 times dy minus dx. If it's less than 0, then we're going to go ahead and add the 2 dy. Now we have the parameters for both the slopes. For when we do y calculated increment x or x calculated increment y. So let's look at them. So the first thing we do is we check to see where we need to increment x and calculate y. If that's true, what we do is we're going to first we light up the first coordinate on the line, which is xi and yi. Next, I'm going to do this while loop starting from the initial x, and I'm going to increment x till I get x to final, because what I do when the slope is less than 1 is we increment x and calculate y. So first question is I'm going to say, hey, is this, if the middle line, which is in this case the initial value, if it's less than 0, then what I'm going to do is I'm going to add the value middle y same, which is the 2 times dy, and then after that I'm going to light up the point, which is going to be xi and yi. So it's going to be the lower, I do not change the y, so I'm basically lighting up the bottom pixel. Now in the case where it is this is not true, so the value is greater than 1, then what I'm going to do is I'm going to take the middle line plus I'm going to add the middle line y increment, which is this value 2 times dy minus dx, and then I'm going to increment y. So what I'm doing here is I'm going to light the top pixel, and then I go ahead and plot the stuff. So I have the x initial. Now the y initial is the y plus 1 actually, and then I turn on that pixel, and then I increment by x. So no matter which one of these two statement I do, whether the middle line is less or greater than 0, I always follow by plotting and increasing x plus 1. And if this middle line is greater than 0, then what I do is I also increment y. So that lights up either the current bottom pixel is going to be light up, or the top pixel is going to be light up. So let's continue. So I did it for the slope that was less than 1. So now what I'm going to do is I'm going to, that wasn't true to continue with the code, for example. So now what I'm going to do is I'm going to increment y and calculate x. So basically I do the same thing as before the code. I evaluate the middle line, and then if it's less than 0, I increment the value and leave the y and light up the bottom x, because in this case I'm calculating x and incrementing y, and then I go ahead and increment Y, or what I do is I light up the tab X, and then I also increment Y. So let's look at the next routine, which is draw 3, 4, 7, 8. And basically the logic is exactly the same. The only difference is going to be the values that we use for the middle line Y increment, middle line Y the same, for positive slope. I should say for slope less than 1 and for slope absolute value greater than 1. So we start here, and the first thing we do, we make sure that the initial values and the end values, initial values are always less than the final values, and we go ahead and put everything, either we fix it or we leave it alone, because according to how the input was provided. Next, we calculate our dy dx, and we calculate the slope. And then we calculate all the different parameters that we're going to need, and we start evaluating. Let's see if the slope is less than 1 as before, in which case we're going to increment X and calculate Y. Then we go ahead and plot our first point, and then we're going to do this over and over till we get to the final X. And in this case, we either we're going to light up the bottom pixel, or we're going to light up the top pixel, and we always increase X because that's where we are. We increment X and calculate Y. So let's look at the final routine here, and basically again this is just this time the slope is going to be greater or equal to 1, so then we're going to increment Y and calculate X. And so we just light up the first dot in the line, and then we are going to traverse Y between the initial value till we get to the Y final. And what we do here is we decide whether we're going to light up the top or bottom pixel. That's what these two if statement do. I mean, what this if and else statement does. And then we plot the parameter, then we increase the Y, and we keep going till we get to the Y final. So with this, I think we're ready to continue with our presentation. Okay, so let's continue with our example. But before that, I would like to note that in this, when we went through this sample, we looked at the code. We have to realize, and I didn't emphasize enough, that in certain cases we actually decrement X. So we don't always increment the number, but when we are in certain zones, we actually decrement the X, and that would be usually when the slope is less than, the slope is negative of the line. So the code is correct, but I didn't say it, I didn't emphasize enough during the presentation. So let's look at the first sample program. So the program, the microprocessor to display the following graphics. So we're going to display lines that are vertical. Then we'll display lines that are going to be horizontals. Then we'll just draw an X. So kind of showing that things are working the way they're supposed to. Then we'll start drawing lines that start in this corner and they just move all around. Then we'll start in this corner, in this top corner, and then we'll do the same thing covering the 4 corners. So we'll do diagonal lines starting from 4 corners, and then we'll draw a square, and finally we're going to draw an arm that goes around the square to show some motion. So let's get going with that portion of the program. So I'm going to go fairly quick through this code because most of it we've already looked at. So let's get going. So we have here the SPI, initializes the SPI, initialize the ports, then we have the SPI write, then here we deal with the display where we send commands or we send data to the display. We reset the display, and here we initialize the display. I think the one thing that is worthwhile mentioning in this initialization, which is a little bit different, is that we set the axis to the 0, 0, which is going to be, actually should say bottom left corner is the 0, 0. That's what this is going to be set up as. Next, we have this routine that says the area where the which defines which pixels are going to be turned on or off. Then we have a routine that's just going to fill up the whole screen with one color. Now this, once we've set up the window area, we have a routine which is going to fill the window area that had been defined. So first we go in, we set up a window area, and then we fill up the window area, or we can fill up the whole screen. Next, here we have a routine that is going to display our characters. So I presented all that before. So all this so far is something that I've presented before in my different presentations on display and SPI. Here I have a routine that writes characters in a particular size, which is a 2 by 2, and this is now a routine that writes the same set of characters but in a different, I would say, font, which is 1 by 1. Then this is the routine that plots. It's going to plot our points of the line, and basically it calls the a routine that is going to set the window area, and then it calls a routine that's going to fill in the area that had been defined by the set window area. And we get the color. Then we have the X0, Y0, S1, and Y1, which are the coordinates for the initial point and the final point. And so as I noted, it just defines the window area and then writes the window area. Now here we have the draw line. We've already gone through this routine. Basically, we said we look at it to see if the line is vertical. Then we are either going to call a routine to write the line in the zone 1, 2, 5, or 6, or we're going to send a routine that's going to draw a line in zone 3, 4, 7, 8, as I already explained. Then this is the actual routine that does the writing, that draws the line, I should say. So in zone 1, 2, 5, 6. And here we have, we just make sure that the initial point are always less in value than the final points. Here we set the different parameters that we're going to use for defining the line. And the first thing we do, as I noted before, is look at the slope, and depending on the slope, we're going to increment x or calculate y, or we're going to increment y and calculate x. Next, we do the same thing, but for zone 3, 4, 7, and 8, and that's what this code does for the different value for two values of the slope. Now, here we have a routine that draws a square, and basically what we do is we just draw lines, and we draw 3 consecutive lines, which start. It has they are parallel, and we do 3, so it looks a little bit thicker, the line. So we do for the 4 sides of the square, we do 4 lines, because one sometimes it looks very thin and it's hard to see, so we do 4. Now let's get to the main program. So we're going to initialize our ports, initialize SPI, initialize our display. Then we fill in the screen of one color. Then we write our typical hello world. And from here, we're going to write horizontal lines. And this loop writes all the horizontal lines. And basically what we do is we have the X values constant, and we start changing the Y, which brings it up. Then for the vertical lines, what we do is we keep the X constant and the Y changes. So it comes up this way, the verticals. Next we clear the screen, and we're going to write an X. So this is going to be in black. It's going to be coordinate 1, 1, 240, 320. 1, 1, 240, 320. Actually, it's from here. So 1, 1, 240, 320. And then we write another one, which is the 1, 320, which is here, and goes to the 240, 1. So that's the next that goes from here up to here. That's what we're requesting. Then next we're going to draw lines that start at the 4097 and they go to 20397, and this line is just going to this position remains constant. Actually, I should say this position remains constant, and then we change the increment the Y, and then when we get this point, then we start decrementing the X, and the Y remains the same. And we're going to do the same thing for the corner of the left corner. Then we're going to do the right bottom. Then we'll do the left top, and finally we'll do the right top. And that's what these routines are going to be doing. Next, we get to the while loop. At the while loop, what we're going to do is we're going to have a continuous rotation arm. We're going to have an arm that rotates continuously around this square. So first we'll draw the square, and then we'll have an arm that rotates continuously. Let me go back here. So you fill in our screens, and there we go. So the idea is that we could the arm could be just one line that moves around, but it's going to be fairly thin. So what we're going to do is first we increment the location every 5 pixels. So every 5 pixels we're going to draw 5 lines that have the same origin, but they go to different places, one next to another. And then so we write that it's going to be color black, and then we write the same 4 lines, but we do it in the color of the screen. So basically what we're doing is erasing the first 5 lines that we drew. So we try 5, wait 5 seconds, and then we erase those, which are basically the same locations, except that one is black and the one is cyan to disappear the lines. So that gives you when you look at these lines, it looks like the arm is moving around. So we'll see that during the when we see the output of the display. Mm. So this covers zone 2 and 1. That's 2, 1. Then we go zone 8, 7. Then we go 6, 5, and finally we do 4 and 3, the zones. So what we want to do is we want to give the illusion that there is a arm moving around clockwise. So let's look at the outputs. So here we start with the parallel lines. So we had our hello world, and then we draw our parallel lines, vertical lines I should say, I'm sorry. Then we clear the screen and we're going to write our horizontal lines. And basically what happens here is the x and y remains the same, and what we're doing is increasing the x parameters stay the same, and what we do is we change the y. Now this is the x. Then we're going to start with the left lower corner, which we start here, and the initial point is constant, and the y keeps increasing, the x remains constant. Then when we get to this point, the x starts decreasing, and the y remains the same as a final point. So that's how we write these ones here. Then we clear, then we go the right lower corner, and again in this case what we're going to be doing is we're going to be incrementing the y, and the x remains constant. The initial point remains constant. Then when we get to this point, then what we have is the x is incrementing and the y remains constant at the final points. Then we're going to do upper right, and basically what we're trying to do here is show that all the lines with the different zones are working fine. And we have one more to go, which is the we start with the right corner upper. So in this case the y is decreasing in value. The initial point stays fixed, we decrease y, and then when we get to this point y remains constant, and what we do is we increase the x value. Next we draw our square, 3 lines each with a continuous rotation, and this is where the arm starts rotating. And basically this is what I explained in 4 lines that come together. They start at the same point, but they go to a little bit different location, different 1 pixel location, the difference. And what we do is we write the 4 lines, and then we rewrite the 4 lines, but at the same color as the display. So this shows gives the illusion of a rotating arm, and so this would be going continuously. But this just gives you the flavor of things that you can do with the display, and once you know how to draw different lines, we can write squares, triangles, and make things move around by writing and erasing. So let's go ahead and continue to go to our next, continue with the presentation. Okay, so let's continue. Now we're going to be drawing circles. So the equation for the circle is the 2x plus I should say x squared plus y squared minus r squared equal to 0. We know the value of the point of the circle, x comma y. Then by symmetry, we know the value of the following points. So if we know x comma y, one coordinate, then by symmetry, we can figure out a whole bunch of 8 points. So if we know x comma y, we can draw this point x comma y, but we can also draw the y comma x by symmetry, y comma minus x comma minus y, minus x minus y minus x, minus yx, and minus x comma y. So what it amounts to is we only have to figure out zone 2 of the circle, and by doing that, we can draw the whole circle. So if I want to draw the circle, all I need to do is figure out the location of the points on zone 2, and the rest can be drawn by symmetry. Now let's look at this for a minute, because when we program, this is usually a source of confusion. So if the center of the circle is x1, y1, which is at this point x1, y1, then the x, y location is going to be, x, y is going to be x1 plus x, that's this point here, and the y is going to be, I mean the points we have to draw is going to be y1 plus y. So this point is the center plus the x gives me this point, and for the y is the y value, the center plus the y value. So the x, y is going to be x1 plus x, y1 plus x. Now let's look at the second value, which is going to be y, x. So let's look at it. So the y, if I want to draw this location here, then it's going to be x1 plus y. x1 plus y gets me this value here, which is this one here. And for the y of this point is going to be equal to y1 plus x. Let's look at another one. Let's look at this point. So the y here is going to be the coordinate for the x coordinate for this point here is going to be x1 plus y. So we get x1 plus y gets me here, and then the y coordinate for this point is going to be the y1 coordinate minus x. Next, for this one, the x value is basically going to be x1 plus x, comma, and the y value is going to be the y1 minus y. Let's draw this one here. The x value is going to be x1 minus x, and the y value is going to be y1 minus y. Now let's look at this particular point. This is going to be x1 minus y, and then this value here is going to be y1 minus x. Now this particular one, the x value is going to be x1 minus y, and the y value is going to be y1 plus x. And finally, we get to the point where the x value here is going to be the x1 minus x, minus y, I'm sorry. Let me start again. So this value, the x value here is going to be the x1, let me put it here. It's going to be the x1 minus x, and the y value is going to be the y1 plus y. Now the important thing about going through this stuff is that when we plot the dots on the line, we are going to calculate x comma y, and that's what we are going to plot. But then we're going to plot all these combinations. And if we don't understand it up front here, then it becomes kind of confusing later on. So let's look at the a little bit of the explanation for the algorithm. So let's figure out how we're going to go about drawing our circles. So from the conclusions reached during the development of the line algorithm, we can derive the following. We know that the radius square r squared is equal to x squared plus y squared, which is the equation of the circle. From there we can come out with a function fx comma y, which is going to be equal to x squared plus y squared minus r squared. Now let's figure out what's our initial value. So what we're going to do is we're going to plug in into the equation, into the function, the x comma y plus 1/2, and then we'll say that the radius will start with a 1 to simplify. So this is just plug in the number, we get this equation, then we just go ahead and expand the equation, and we end up with a initial value for our equation, which is going to be, our initial equation is going to be 5/4 minus r, 5 divided by 4 minus r. Next, we're going to calculate the next y by adding one of two values. The first value is going to be if the y has incremented. So and as we're going down on the circle on the first quadrant we're looking at, then we have to decrease the y. So we start with y minus 3/2, and we assume that the y changed, so we subtract this number, which is y minus 1/2, and develop that into the equation, plug that into the equation, I should say. And then we develop the equation, and we end up with a value of 2x sub I minus 2y plus 5. So this is what we're going to use to increment y if y has been changed. Now, if y remains the same, then we take these two numbers and we plug them into the equation, and we go ahead and expand the equation and solve the equation, and we end up with a value of 2x sub I plus 3. So we have our starting value, the value we increment if y was changed, and the value we increment if y wasn't changed. And I should say, when I mean increment, that could be addition of subtraction, depending on what we're dealing with. So let's look at the how we're going to code this. So we first evaluate the 5 divided by 4 minus r, and if the value is 0, then we're going to, and y was decremented, then we're going to use the value 2x minus 2y plus 5 as what we're going to add. Now if it's if this value is less than 0, then the y remains the same, and we use the 2x plus 3. Now if this value is greater than 0, then we're going to use the 2x sub I minus 2y sub I plus 5, and y is decremented. So let's look at the code. So the function is going to be the draw circle, and the inputs to the function is going to be the color of the circle, the radius, size of the radius, and then the x center and the y center. The x and y coordinates of the center of the circle, I should say. So we start by assigning the the initial values, and here our start is going to be the 5/4 minus the radius, and the next value that we have to add if y remain constant is going to be here, 2x 2 times x plus 3, and the value if the y was changed, which is 2x minus 2y plus 5. So we start as usual to ask whether or not the value is of the x start is less than 0. If it's less than 0, then we don't want to increment y, we want to leave y the same. And what we want to do is we want to add to the star equation the value when the y is not changed, which is 2x plus 3. So then the new start equation is going to be x start plus next with y remain constant. Then after doing this, we increment x and then we plot all the dots on the of this that represent the circle, which are going to be 8 dots. So as I explained before, it's going to be the x center plus the y sub I, the y center plus the x sub I, or any of the different variations that I already showed, which are going to give us our x comma y, x, y comma x comma y, and so forth and so on. So we plot our 8 points from the first time we go through the loop. Then we go again, and we're going to do this while x is less than I. So we continue, and let's assume that in this case the start is greater than 0. So in this case, what we're going to do is the next value, the next y value we change is going to be 2 times x of I minus 2y plus 5. And the new start equation is going to be the current start equation plus the next, which y has changed. And then we go ahead and modify y by subtracting 1. And then again we increment the x. And we plot our 8 points. So we continue doing this until we draw the circle completely when this is not true anymore. Now let's continue with a sample, with an example, so we can see how this works. Okay, so let's look at an example. So we're going to write a program that is going to display 3 circles. The first circle is going to have a radius of 70, and it's going to be centered at location 121,183. Next, we're going to have a second circle, which is going to have a radius of 20 and be located at center at 121,183, which are 2 concentric circles basically. And then we'll have another circle which is going to have a radius of 50, and it's going to be, the center is going to be 119,120, which is one that is going to be off center. So we have 2 concentric circles and one that is going to be off center. So let's figure out how we do this. So let's start. I'll go ahead and go through this code. I'm going to go fairly quick because we've looked at most of this. We've looked at all the code, I should say. So we have here the routine to initialize the SPI, write to the SPI. Then we have a routine to send commands and data, and a routine to send data to the display. Then we can have a routine to reset the display. Then we have a routine to initialize display. Now here we have a routine where we set the window area where we plan to turn on pixels. Next we have a routine that fills up the whole screen. At the start we just want to make sure we clear the whole screen. Now we have here a routine that fills a window area. So we had a routine that's pre-selected an area, and this is the routine that's going to fill the area that we selected. Now we have here a routine that display characters. Next we can display the characters in a what I call a size 2x2 or 1x1. Next we have a routine that plots, which is what we are going to use to do all our circles, and we used to do our lines also. So what I have here is the first thing we do is we set the window area, And once we set that window area, then we fill the, we turn on the pixels on the area that we have pre-selected. So next we have here a draw circle, which I explained, which we evaluate the equation whether it's greater or less than 0, and according to that we increment or decrement. We decrement the y or remain y the same, and then this is, once we have one dot, we can, by symmetry, we can plot the 8 other dots. So let's look at the main program, which what we have here. We're going to initialize our port, initialize our SPI, initialize our display. Then we clear our screen, wait 3 milliseconds, and then we write the hello world to know everybody that we're up and running. And next, what we're going to do, we set up a color, and then we're going to draw 3 circles. One diameter 70, one diameter 50, and the other one diameter 20. Of those 3 circles, 2 are going to be concentric, meaning that they'll have the same center. So that would be the one with diameter 70, which is 121, 183, the x and y coordinates for the center, and then the one with diameter 20, which is the 121 and 183. And then we'll have another circle, which is 50, which is going to be at a different center, which is going to be 110 to 120. So let's see what's the output of this routine. So we have our hello world, and then we have our concentric circles and one that wasn't concentric. So that kind of shows you the what the output of the routine is going to be. So we can go ahead and continue with the next example in our presentation. Okay, so let's go through the final example. And I know this is starting to be a fairly long presentation, but we need to get, this is the last one. So we're going to write the programs, the microprocessor to display a rotating arm around a circle. So we have a circle, and we're going to have a rotating arm, like it was a chronometer. So the circle is going to be a radius of 86, and the center, the coordinates is going to be 121, 183. So let's look at the at how we go about resolving this problem. Okay, so let's try to figure out how we're going to go about programming the arm that rotates around a circle. So if the circle is at the location center of the circle, I should say x, 0, and we have a radius of r, then the end of the line we want to draw is at the following coordinates. It's at the x coordinate, which is going to be equal to the x sub 0 plus r cosine of theta, and the y coordinate is going to be equal to y sub 0 plus r sine of theta. So basically what we're going to do is we're going to draw lines that start at the center of the circle, x0, y0, and they're going to end at the point on the circle, which is going to be the x, y, which is going to be x is going to be x sub 0 plus r cosine of theta, and y sub 0, which is going to be y, which is going to be equal to y sub 0 plus r sine of theta. Now, as we change the angle from 0 to 360, the line endpoint moves around the circle, basically. So let's figure out how we're going to, let's look at the code, how we do this. So we're going to have a routine that is called draw circle rotating arm, and the inputs are going to be the color of the circle we want, the radius of the circle, and then the center, the x and y coordinates for the center of the circle. So so we're going to have a loop that goes, starts at 360 angle and then decrements by 5, and it's going to go as long as the angle is greater than 0. So the first step we have to do is we have to convert our angles to into radians, because the formula for the cosine expects to get radians. So that would be the radians is equal to the angle we get times pi divided by 180. So our x is going to be equal to initial x, I should say, is going to be equal to this x, the center, plus the distance to the circle, which is going to be the radius times cosine of the radius that we calculated, which is based on the angle, and the y value is going to be the y center plus the radius times the sine of the angle in radians. So once we get the x and y, those are the final points of our line, then we are ready to draw a line. So the line is going to be, we have a color for the line, so we have it's going to be the first point of the line is going to be the center, x comma y, those are the coordinates of the center, plus the x plus 1 comma y plus 1, which is the x and y locations of the end of the line. Now what we do here is we're going to draw three lines, x plus 1, y plus 1, x plus 2, y plus 2, and then x plus 3, y plus 3. So what I do is every time I go around, instead of just having drawing one line, I draw three lines, so it's a little bit thicker. And then once I draw the line that goes from the center to the end of the to the circle, to the edge of the circle, then what I'm going to do is I'm going to draw the same lines, but with a color which is the color of the display, original color, so it disappears the line. So here I draw the lines and here I disappear the line, then I go again with a different angle and I draw the line and I get rid of the line. So that's going to give us the illusion that the arm is moving around. So let's look at the whole code and then we can see the output and see what this looks like. So let me just recap. So we draw lines from angle from 360 to 0, increments of decrement of 5, and then we calculate the x and y locations of the line to the edge of the circle, and then we draw that line that goes from the center of the circle to the edge of the circle. So let's look at the code. So again, I'm just going to go fairly quick because this is something that we've already looked at. So we have it is going to be fairly long because now we're going to be writing messages, we're going to be drawing lines, and we're drawing circles. So we have here the initialize SPI, initialize our port, SPI write, then we send commands to the display, send data to the display, we can reset the display, then we initialize the display, followed by we set the window area where we want to turn on the pixels or off, then we have a routine to fill in the screen and basically it just turns everything on in a color that we select. Next we have a routine that fills the area of the screen that was selected by set the window area. Next we display characters, and those characters can be of 2 dimensions, can be 2 by 2 or 1 by 1. Then we plot our circles and lines, which basically we set the area and then we turn on the fill in the window area, which is turning on the pixels. Then we have here draw line, which we did on the first example. So we looked at the light is if the line is vertical, and then we select in which zone the line is, and then we go ahead and draw the line. Next we have here a draw a square, and what we did in our prior example, we have how we draw the circle, and then finally we get to the point where we draw our circle rotating arm, which we just looked at a couple of minutes ago. So let's go to our main program. So we're going to initialize the ports, initialize SPI, initialize our display. Next we're going to fill in our screen, and then we're going to write our hello message. Next we're going to draw a circle, and we draw the circle using 1, 2, 3, 4 lines, and they just change a little bit so we can the circle's a little bit thicker so we can actually look at it a little bit better. Then we send our hello message, and now our circular arm is going to be in the while loop. So what we're going to do is we draw the rotating arm, so we go 360 degrees. Then we send a message that displays go again for 200 milliseconds. Then we display the same message, wait for 100 milliseconds, and then we draw the arm again. So let's look at the output to see what this looks like. So here we go. So we have our thick circle, and then we're going to go around. Of course, this is fairly crude as way to do it. I mean, there's a lot of, it has to be improved, but this kind of gives you a feeling. So once we get here, we're going to send display message, say, hey, go again, and then the circle goes again. So this is just to give you flavor, things you can do here, but you know, the lines, the way they look, that can be improved many ways that you can research how to do that. So here we do again, and we are going to show the go again. So that gives you a good idea of how to set up a circle and how to have an arm moving around, and that gives you a new dimension to things you can do with your display. And of course, this is just very crude and very preliminary way that you would do something to see how things look. So let's go ahead and continue with our presentation. Okay, so let's continue. Next is the summary. So today I showed you an algorithm for drawing lines, and we went through a sample program. I also showed you an algorithm for a circle, for drawing circles, and we had a sample program. So I hope you've enjoyed this presentation. It was kind of long, but I wanted to make sure that I put lines and circles together so you would have those, they come of goes nicely as graphics. So again, thank you very much for taking the time to spend with me, and I hope I see you the next time.